Okay, we're going to continue our analysis of slope and velocity graphs. So if you recall, by finding the slope of a velocity time graph, so the change in the velocity over the change in time, we're really finding the acceleration. So here in this particular example, if you recall, the acceleration was equal to my change in velocity, 6 meters per second towards the north, over the time interval, 4 seconds, which gave me 1.5 meters per second per second. So my velocity changed by 1.5 meters per second towards the north every second in time. We can also write this down as 1.5 meters per second squared north, or my acceleration. Let's look at a few examples now. So on this page, you can see that I've already marked off the different intervals, and we can look at the slope. So here, in the first example, you can see that my velocity is not changing. So in other words, I have a constant velocity, and when we have a constant velocity, I don't have any acceleration. So my acceleration in this case, or slope, is going to be equal to 0. So again, it's a constant velocity that we have here. Now similarly, in the second object here, you can see that we're motionless at the beginning and we stay motionless during the entire time interval. So again, here my acceleration would be 0. I have no change in motion, 0 slope. So again, here I am motionless. So I'm not changing what I'm doing, in other words. My motion stays consistent, or I'm motionless. It's not changing. Now in C, you can see that I'm going from 2 meters per second to 6 meters per second, and this takes a grand total of 4 seconds. It's very similar to the previous example. So here, when I find my acceleration, I'm going to find the change in the y, change in velocity, so it'll be 6 meters per second minus 2 meters per second. And this occurs over a time interval of 4 seconds. So it'll be x2, 4 minus 0. And we get 4 meters per second over 4 seconds, which gives me a velocity, or sorry, an acceleration of 1 meter per second, or 1 meter per second squared towards the north. So in other words, every second my velocity is increasing by 1.5 meters per second towards the north. Now the last example, I'm going from 4 meters per second to north to 2 meters per second south. Now here, I'm going to avoid using negative numbers as part of my slope. So I'm going to use this point over here, and the 0, the intercept with the x-axis here, x-intercept, as my 2 points. So in this situation, when I look at the slope, I have to change in velocity. You have to be careful here. My y2 is 0. y1 is 4 meters per second. So really be careful there. The negative slope you should have here. So 4 meters per second change is going to be more negative all over a time of 2 seconds. And when I do that, we're going to get a value of negative 2 meters per second squared northwards. And we can write this as an acceleration of 2 meters per second squared south. So in other words, my velocity is increasing towards the south by 2 meters per second every second. So it makes sense. Initially, I was moving northward, coming to a stop here. So if I'm moving northward to stop, I have to accelerate in the opposite direction. I'm accelerating southwards, coming to a stop, and then continuing my southward acceleration with my velocity becoming more south. And that's it for finding the slope of velocity time graphs.